Okay, so now that we've learned what similar polygons are, we're going to decide if two polygons are similar. Do they meet the criteria? Remember, two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. The similarity ratio of two similar figures is the ratio of any side length in the first figure to the corresponding side length in the second. To prove that two figures are congruent, that two figures with congruent corresponding angles are similar, show that the corresponding side lengths are proportional. So here we go. I have two triangles. I know that their corresponding angles are congruent. I want to show that they are similar. Notice what is marked as congruent, right? W and X are congruent. Y and R are congruent. And B and H are congruent. So that tells us which pieces are corresponding to the other. Let's use that to find which sides are corresponding. So when I connect X and H, notice I had labeled them in colors, right? So I went from the red angle to the green. So in the other triangle, I'm going to go from, again, the red angle to the green. So X and W are congruent, so they're corresponding. R and Y are congruent and corresponding. So the sides between those 2 points are corresponding. Next, let's go with X and H. So from X to H, that color's too similar. From X to H here, I go along this side from the red to the pink. And so that would correspond with W to B. And then for the last one, of course, RH corresponds with YB. So we're going to use these corresponding sides to compare the ratios. So let's start with side length BY, or side BY. And when I set up my ratio, I'm going to put BY in the numerator, and I'm going to compare it to which side? Which side is corresponding to BY? Well, we said that was HR. So I'm going to put BY over HR. Now, the ratio is BY is equal to 4.2. So I'm going to fill it in, 4.2, over HR is 2.52. And now I want to see what this ratio is equal to. So in your handy calculator, we're going to do 4.2 divided by 2.52. And we get 1.6 repeating, right? It's 1.6666667 because it's rounded. You could round to 1.7. I try not to round because we want to be as exact as possible for these ratios. So I'm going to do 1.6 repeating. All right, let's fill out the next ratio. So we started with BY. Now let's go YW. And we know that YW corresponds with RX. So now let's fill in the information we know. We know YW is 12, and we know RX is 7.2. So we're going to use our handy dandy calculator again. 12 divided by 7.2 is, oh, look, these two are the same. That's looking pretty good. Let's double check with this last side. All right, so we did YW. Now let's do WB. So we've got WB over WB corresponds with XH. Plugging in what we know, I know WB is 10 over XH is 6. Pulling out my handy dandy calculator again, I feel like Blue's Clues. 10 divided by 6 is 1.6 repeating. Look at that. All three of the ratios are the same. What does that mean? That means that these are two similar triangles. So the last thing we have to do after we have decided, yes, these are similar, is to write a similarity statement. Just like with congruent statements, we list them in corresponding order. So let's say I say WBY. WBY corresponds with XHR. So that is how I could list this. Now notice I went from W, which has 1 tick mark, to B, which has 2, to Y, which has 3. So again, in here, I have to go from the 1 to the 2 to the 3. And there's our similarity statement. All right, let's do the same thing here for part A. Again, I'm going to start to compare in order to determine if these are similar. I know that all their corresponding angles are congruent, right? They're all right angles. I have 2 rectangles. But now I need to check out the sides. So for these ones, the corresponding side here, AB, corresponds with EF. And AD, well, those are 2 similar, corresponds with EH. I'm going to do a little squiggle so we can tell the difference. Now remember, in a rectangle, opposite sides are congruent. So with a rectangle, we really only need to check the length and the width. Since these opposite sides are congruent, if I were to set up the ratios for the other sides, it'll give me the same exact result. So because only for like a rectangle, maybe a square, certain things like that, right? If it has congruent sides, we only have to do it for the sides that are different. All right, so let's set up our first one. Our first ratio, I'm going to start with side AB here. And AB corresponds with EF. So when I set it up, AB is 6, EF is 3, and 6 over 3 is 2. Didn't even need my handy dandy calculator. Let's try the next one. So AD is the pink side in the first rectangle, and then that corresponds with EH. AD is 15, EH is 10. Now this one doesn't come out perfectly. We can use our calculator, but right away I can already tell it's not going to be 2, right? This one is 1.5. Okay, are those 2 ratios the same? They are not. So these 2 are not similar. They both have the same shape. They're both rectangles. They have different sizes, but their sides are not proportional. That's what we see by these 2 different ratios, that the sides are not proportional. All right, you're going to go ahead and try B now on your own. Make sure that you match up corresponding pieces, and notice that if you have sides that are congruent to each other, you might not have to do all the ratios you think. Give it a try.